I want to provide a brief introduction to the concept of a Monte Carlo simulation. What it is, it's a method for dealing with uncertainty. So instead of using average values for the variables we're interested in, we allow the variables to change randomly, and we do numerous replications of our model to see how things change and to see the results we get. For example, you've probably seen forecasts for the track of a hurricane. The hurricane path modeling takes into account various factors including atmospheric conditions, sea surface temperatures, wind patterns, and the impact of high and low pressure systems. So sometimes instead of seeing a cone or just a track of it, sometimes they will show you this entire replication they've done. And it looks like a bunch of strands of spaghetti, and you can see each one of these is a different replication. So in this case, some of them aren't going to get close at all to land, and some of them are going to go quite far into the US. So they do these simulations, and then what they do is they look at the most likely scenario. So if you look at these, there aren't too many that go deep into the US, and there aren't a whole lot that go way out to sea. Most of them seem to hit in here. So the cone or the path that you usually see drawn would be something like here, and it would be not just one line, but sort of like I said, a cone that shows you the possibility of the different places it'll hit. So using statistical distributions like the normal distribution allows us to generate random variables based on the mean and the standard deviation. So you maybe have seen this graph in a statistics class where they show you this normal distribution has a mean of mu, and that the variables can have, plus or minus 1 standard deviation is about 68%, plus or minus 2 standard deviations is about 95%, and plus or minus 3 standard deviations is over 99%. So if we had a project that cost $1 million and has average annual cash flows of $250,000 and a standard deviation of $100,000, if it's normally distributed, 68% of the time we're going to expect the cash flows to fall between $150,000 and $350,000. And 95% of the time we'll expect it to fall between $50,000 and $450,000. And 99% of the time we expect it to fall between minus $50,000 and up to $550,000. So what are the steps for a Monte Carlo simulation? You specify the model. In the case of the hurricane, they're looking at atmospheric pressure, wind speeds, temperature, etc. In the case of financial modeling, for example, a capital budgeting problem, we're going to look at what's the model we're looking at. We're going to use NPV, and how are we going to calculate NPV? We're going to specify a distribution for each variable in the model, and then we're going to do a simulation using these variables to produce one outcome. And we're going to do a lot of replications of it, just like that picture I showed you of the hurricane. So they don't do just one replication, they do thousands or maybe tens of thousands, and then you look to see on average where it winds up. So if we happen to be doing capital budgeting, some of the random variables might be the price we charge for the goods, the quantity sold, variable cost might change randomly, and interest rates. And we allow all of these variables to change based on their mean and standard deviation. So we're not changing one variable at a time, like only price. We're allowing price might change, and quantity would change, as well as variable cost and interest rates. And we calculate an NPV. And we do many replications of this, and then we'll look at the average NPV to get a better idea of whether the project is viable or not. And after doing, for example, thousands of replications, we're going to get a distribution of the NPVs. If the distribution of our NPV indicates that, let's say 90% of the time, the NPV is going to be positive, then we can feel fairly confident about pursuing the project. If it turns out to be the case where, we only get a positive NPV 35% of the time, then we probably want to forego the project or modify what we're doing and reconsider the investment. So this gives us a better idea than just looking at a bunch of average numbers. The average numbers may give us an idea, well, the project looks good. Or just changing one variable at a time may be sort of interesting, but tells us how sensitive the model is to a change in a variable. But changing all of the variables at together gives us a better idea of the type of certainty or the type of likelihood that we're going to have a good project. So in some other videos, I actually show you how you can do Monte Carlo simulations in Excel. It's quite easy to do. But this one, I just wanted to give you an idea of what exactly a Monte Carlo simulation is. So thanks for watching.